We're looking at section 4 of the lines and triangles unit, and we're going to start out with a bunch of proofs here, and we're going to do one proof per video, so each video will be hopefully reasonably short. First one says, I'm going to start out with what we're trying to prove. Triangle MNQ is congruent to or equal to triangle PNQ. So we're trying to prove that those two triangles are the same triangle. And the information we're given is that NQ bisects MNP. So MNP up here, we're told that this line here bisects it, and when things bisect it, we know we're going to get equal pieces, so we'll want to take note of that later. And we're also given that NMQ, also angle M, is equal to angle NPQ, which would be angle P. So angle M here and angle P are equal. And sometimes these things are already marked for us on the picture, sometimes they are not. So we're going to go through and make sure they're all there. We want to prove the two triangles are congruent, and the only thing that I see being shared here is a side. So let's go ahead and mark our shared side right away, because that's free information. And I believe that that might be all we need. We have an angle, we have an angle, and we have a side all in a row. So angle, angle, side is going to be our plan, how we're going to do this. So now let's try to write it out more formally. We start out with our two-column proof here. We begin with our given, and that's going to be that NQ bisects, and let's just practice writing this even though it's given to us here, bisects MNP, and then NMQ is equal to angle NPQ. So that's all given. Now we need to start making our next jump. We said that these angles are equal, and we knew that because of the bisector. So we need to say that explicitly. So we have angle MNQ, let's keep your letters straight, MNQ is equal to angle PNQ. And we know that by the definition of what a bisector is. So definition of bisector. So now we have our given angles here. We have the angles that we just found out from the definition of the bisector here. We need to say something about this side, this NQ that's being shared. So we're going to say that NQ is equal to NQ. And the reason for that is reflexive. So by the reflective property, we get that NQ equals NQ. Now we have our angles, and then our sides that are equal. So I can now say by angle side that triangle MNQ is congruent to, and I have to make sure everything matches up here, the angle with two marks first, so triangle P, then the triangle with one angle with one mark here, N, and then the unmarked angle Q. And that would be our proof.